Welcome at Supercomputing 2022 in Dallas. I have the pleasure to have with me at the Swiss booth one of the pioneers of HPC, Horst Simon. So Horst, first of all, thank you very much for your time, for your visit at our booth. So you have really been in this business since the very beginning. So how do you see the future of HPC?
Well, generally, I think the future of HPC is bright, simply because if I observe worldwide, what I've also observed locally at our lab in Berkeley is that using computation as a tool in science has taken hold. And right now we have 16 different divisions in Berkeley Lab. Every single division from astronomy, astrophysics to basically high energy physics, particle physics to biology, and everything in between, materials, chemistry, environmental modeling, they all use high performance computing. So I think as a scientific tool, HPC has taken hold and it can only get better.
That's very nice to hear, but we hear a lot about the problem of the energy consumption, of the HPC footprint. There is a lot of discussion also in supercomputing about this. So what do you think, how can we cope with this new aspect of the HPC business? How do center will have to react to this?
Yes, so there are basically two ways to answer that question. The one is the immediate increase in energy prices. And so I think everybody is struggling with an increased cost. But then there's the other way, and this is the long-term concern that always has been expressed. As scientists, we're always concerned, are we increasing the carbon footprint by building bigger and bigger computers? So both call for more energy efficient computing. But I'm also very encouraged by what we've seen in the last 10 years, how much the flops per watt have improved. And now we have systems that are delivering in excess of 50 gigaflops per watt. And this is a figure that 10 years ago was a target figure. And so I think that trend hopefully will be able to continue. Now, the challenge is, are there actually technologies on the horizon that will help us in the future? And we have to, if you're looking back the last 10 years, we need to acknowledge that the one big boost that has improved the energy efficiency was the move towards accelerators. Yeah. And so this was a one-time architectural change which got us really on a new trajectory. Now, if we don't change the trajectory again, we will see only moderate improvements in energy efficiency.
So we should look at this as an opportunity for new ideas to come.
Yes. So I think this was an interesting part of the top 500 discussion yesterday. So what do we expect to see in 5 years in terms of top 500? Because if you look at the predictions, it may be until 2030 until we can see a 10 exaflop machine. So the next just factor of 10 may take 8 years, which is a long time, because previously early on in the history of high-performance computing, we saw a factor of 1,000 in 8 years. And so the future, in the next 8 to 10 years, we really need to find a new technology that gives us another one of those boosts. And I don't know what these are, but there are some companies out there that are promoting technologies different from CMOS to build chips. And so maybe I shouldn't say this here because this is a company I have a non-disclosure with, but there's a company out there that claims they can be 200 times more energy efficient by switching to different technology, and this is a very well-funded startup. Then the other one is that maybe we have to look again at speeding up the clock cycles, because the current processor technology really stagnated at a few gigahertz. and nobody's talking about how to get these higher. And so there's also technology out there that would allow us to have processes at higher cycle time.
So
add more is that the actual cost is the cost of moving bits and not of flops. And so we need to also look at different interconnect technologies.
But this means that there is a lot that is still
There's a lot that needs to be done.
Exactly, there's a lot that needs to be done. So, Horst, I want to ask you, you know Switzerland a little bit, you have visited us many times. Do you think it still makes sense for a country the size of Switzerland, so 8 million inhabitants, to have a super computing center, a facility, an independent facility in the European and world scenario?
I think yes. And the answer is simply this, is that supercomputers have three main reasons. One is for intellectual progress, for science. The other one is for economic competitiveness, and the third one is for defense. So I don't know whether CSCS has any role in national defense in Switzerland, but certainly in terms of intellectual competitiveness, it is essential to have an HPC capability, simply because, as I said, science has become much more computational, and we will see more progress based on computational science. So as long as Switzerland wants to have an elite university like the ETH, it is essential to have the corresponding supercomputing facility.
Thank you very much, Horst, for your time. It has been a real pleasure to have you here, and I hope you will enjoy the rest of the conference, and see you in Denver.
Yes, I'm looking forward to Denver already, and I always enjoy visiting Switzerland, ETH, and Lugano, CSCS. Yeah. So I'm looking forward to seeing you there again sometime.
And we will be happy to see you there. Thank you.